Okay, let's just review the content until now. We know that it took easily 3.6 billion years for life to get here after a set of very unique conditions were suitable in this planet for there to be life. And again, these conditions are pretty rare by comparison to all of the planets that we know exist in the universe. Once the species got to be here, they spread out and they occupy what is called the geographical range. Inside that geographical range, they created different body sizes and abundances, and they managed to get all the way up to today, where they account for easily 8.7, 8.9 million species. Along that way, there have been multiple times, up to 20 times, where there has been extinction events, species going extinct, and in that history, we found that there are only about 5 events what are called mass extinction events. Those are periods of the time, periods in the history of our planet where over 75% of the species went extinct, and we only know of 5 of those in the last 500 million years. And it gets us up to this point now in which these species are sharing the planet with us, and despite the fact that today we are causing the decline and extinction of some species, we are not there yet at what is classified as a mass extinction event. But it looks for the data that the speed at which we are causing the decline and extinction of a species is fast enough for us to get to what is called a mass extinction event by the end of this century. Last class, we started to look at why this is happening, and we were looking at what is called overexploitation. Today, we are going to be moving to the second major reason of the loss of a species, what is called habitat loss. The definition of habitat loss basically is the reduction of hospitable locations for individuals of a species. I want you to think about the generality of this definition: reduction of hospitable locations for individuals of a species. The reason why this definition is broad is because commonly people associate habitat loss with deforestation. Things are very obvious to you, like you just go and cut down the trees and now the habitat that is there is lost. With the immersion of climate change, it has been found that many species lose the capacity to live in certain places. On those cases, it's not that we went and wiped out, destroyed their habitat directly, but indirectly through changing the environment, we made it impossible for many of these species to survive there. And that obviously adds to things like pollution, habitat loss that is found not only on land, but in the ocean, and then the issue of climate change. All of these examples are cases where a species lost the capacity to live on those places, and that is defined as habitat loss. Let's have a look about the magnitude of habitat loss. This is one example that I found remarkable. Actually, just points out to you the scale at which we are destroying habitats that is now even visible from outer space into the oceans. This is, for instance, shrimp fishing in some place in China. You can see the boats as they move along. They are pretty much dragging these nets on the ground, killing and destroying pretty much any habitat or surface that is at the base of these oceans. And you can see the array of boats there. Basically, we're just like bulldozers that destroy the deeper parts of the oceans. And again, this is just one of hundreds of examples there on the direct destruction of habitats. Unfortunately, the magnitude of this destruction is massive. On land, it has already been established that easily 38% of the land of the oceans is occupied for us alone just to produce food, agriculture. Again, when you look at the footprint of agriculture, which is required to feed humanity, that footprint is already 38%. Doesn't sound like much, but what you gotta think about is that that's just the hospitable are the best locations in the planet. We just left places where species cannot survive as the ones that we just don't use for agriculture. Pretty much any nice place that can be farmed, we already took it, to the point that we already took 38% of the surface of the land just for the purpose of agriculture. We saw this figure, a different version of this figure. This is the similar figure, but from a different assessment called the Millennium Ecosystem Assessment, which look at the deforestation by regions. So you can see how, for instance, in the Mediterranean forest, for instance, that people there in the Mediterranean already destroy easily over 70% of the land. You can see here the footprints, right? Those are scars, right? So basically what we did on these places that you see in brown here, we went and we just denuded the land of natural ecosystems there. And you can see the massive footprints, of course, in in Europe, China, India, North America, and now South America as well. And you can see the places that humanity hasn't done much are normally deserts or places at higher latitudes. Everywhere else that is kind of suitable, we have taken that for the purpose of agriculture. And you can see that the magnitude of destruction is already massive already. Unfortunately, as I point out to you in the last class, not only already we took an incredible amount of land, we also continue to take more land on the order of 6 million, 7 million to 10 million hectares of forests cut a year. As I told you in one of the last classes, this number is very variable depending on what is accounted as deforestation. So I want you to think about this. We already took nearly 80% of the surface of the land. We take 10 million hectares on average a year. And the other thing that we are doing is that our agricultural practices are so terrible for the environment that this land become incapable of producing food, right? What is called desertification. And basically what it is just lands that become completely useless. Hawaii, for instance, is a good example of that. You can see that on many places where the only thing that grows here are weeds, but because again, the use of the land has been so extreme that natural ecosystems had a very hard time to recover on those places. And that's called desertification. So think about this. We took already 40% easily. We move forward, destroying more land at a rate of 10 million hectares, and behind we leave 10 million hectares destroyed. So this number of the 40% area that is used for agriculture remains stable despite the fact that we gain 10 million hectares a year. And the reason for that is because we lose 10 million suitable hectares as well. So again, we are nothing different from a cancer that just keep moving, destroying things as we move along and leaving behind a sea of destruction there. That is the landscape on land. I mean, I wish, I pray to God sometimes just to give me the right words to convince people of the seriousness of this problem and the consequences of what we are doing to many of these species on the planet. And unfortunately, we are failing at that. The situation obviously is a lot worse. It could be just as bad in the oceans. As I mentioned to you already, this assessment, for instance, points out that on the oceans, coral reefs already easily, we lost 25% of them. And this is in 2004, this assessment, this is global assessment. So these global assessments are difficult and they don't come that often. But 2 or 3 years ago, there was another global assessment, quick assessment, that suggested that easily already 50% of the world's coral reefs could have been lost during the last decade to bleaching events alone. Unfortunately, things are going to get a lot worse. Well, so far, we have gone through landscapes in a wave of destruction, mostly for the purpose of using land for agriculture and development. There is a coming wave as a result of climate change. That wave, again, is not going to be directly as destroying the thing, but as changing the environment that is going to make it unsuitable for a species to survive on those places. This is one of hundreds of examples of the projected changes of climate change on land. And you can see here, for instance, the places that we are not there yet, because either they are too cold, are the places that are going to be impacted by climate change the most. So basically, those few places where we haven't managed to get directly, we are going to get there indirectly via this effect of climate change. And the combination of that, of course, is that we're just leaving no place for the species to survive. The conditions are just as bad in the oceans. In the oceans, actually, I had a student of mine that is just finishing a paper on this, pointing out that the climatic changes that are happening in the oceans is actually accelerating the speed at which species are losing habitats there. So what happens in the oceans is this. So we know that the tropics are heating up, right? They're picking up a lot of heat. As a result of this warming, tropical areas are becoming unsuitable for coral reefs. So the coral reefs now seems that they will have a chance to survive at higher latitudes where the temperatures are not as hot. Unfortunately, in the oceans, another consequence of climate change is acidification. And acidification, what it does, it reduces the amount of calcium carbonate in the water, and unfortunately, that's more severe at higher latitudes because thanks to the colder temperature, the calcium carbonate precipitates faster. So basically, these climatic changes that we are doing, thanks to acidification, acidification are making higher latitudes unsuitable for corals to survive. So basically what you can see there is that we are chopping off the escapes for coral reefs, while in the tropics we are hitting them, and the species of corals might find higher and lower latitudes suitable for them to survive. At those higher latitudes, climate change is also truncating their capacity to escape, mostly again because of the fact that acidification is more extreme at higher latitudes. Let's understand, just like we did before with overexploitation, how does habitat loss influences biodiversity. So as I explained to you earlier, when you look at the size of a population, the size of that population is regulated by 4 demographic processes. In the inputs, you had immigration and natality, and in the output, you had migration and mortality. One thing that we need to pay attention to is these 2 demographic processes related to migration, right? And interestingly enough, that migration is linked to individuals that come or go to other populations, right? So you can either get new individuals added via immigration or new individuals from here leaving and then adding to other populations. And there, in this connectivity is where habitat loss has one of the strongest effects. This interaction of populations that are connected by dispersal is what is called metapopulations. Okay, when you get a population, again, it's just the number of individuals on a given area. Metapopulation is these patches of populations of the same species that are connected by dispersal, and that's these metapopulations is where habitat loss has their strongest effects. Let's look at an example here. Here you can see an example of a butterfly species, and the numbers that you see there is the sizes of the populations, and the patches is the habitats. And you can see here the number of individuals that go from one patch to another one, and this entire set of smaller populations becomes what is called a metapopulation. This is a good example for us to appreciate the significance then of habitat loss. So from these attributes of a metapopulation, you can appreciate that something that is important for the maintenance of that metapopulation is the patch size. How big is the patch? The other one is the isolation of the patch, right? So if a patch is too far apart, the capacity of individuals to move between patches is reduced. So basically you reduce the capacity of individuals to move. And the other attribute of metapopulations as it relates to the habitat is patch quality. So obviously you have good resources and good quality, you can, as a population, do much better there. So these attributes, again, relate to the habitat, patch isolation, patch quality, and patch size, and they are fundamental to these attributes of immigration and emigration that, as we explained, influence the size of the populations. So habitat loss plays to those factors. So here is an example, for instance, related to the patch size. And this is again a couple of hundreds of examples showing that as you increase the habitat where population can survive, normally the number of individuals increases. This is an example, I believe, for butterflies. This is another example for butterflies as well. You can again see that at the habitat where the species can grow increases, so is the number of individuals that those habitats can survive. So patch size, again, is an important attribute to sustain the population because it allows them to have more individuals. So when you start destroying the habitat, basically you are reducing the size of those patches, so you reduce the sizes of those populations. Now, patch size has another effect, what is called, that is related to what is called age effect. So here you can see an example, for instance, a landscape that has been destroyed by agriculture, and everybody loves their tiny farm to grow all kind of things. But then we leave these smaller patches for the species that were once found everywhere for them to live. Interestingly enough, it has been found that these patches, when they are very small, the species just go extinct fast. So despite the fact that we're leaving some patches for those species to live there, they are dying off. The reason is this thing called age effect. Basically, this intersection between the landscape that is being destroyed by humans and the landscape that is left for the species to survive. That boundary there creates something that is called an age effect, and it has consequences for the species, for the populations inside those patches. Let's look at some examples here. One of them is the increased risk of parasitism or disease, right? So you think about it, on the patch, the species are vulnerable, right? Any species that decides to put eggs or whatever on the patches becomes prone to any big animal or anything that wants to eat it from this side. So basically, you cut by half almost the area that the species can be safe. Obviously, this one is another big one, increases the risk of predation. There are also different microclimates there. You can imagine this area being completely dry because it's completely exposed to the sun, while that one there probably has colder temperatures and moist. So these differences in microclimates prevent species to do well there. So again, unfortunately, the smaller the patch, the larger the boundary of that patch, and as a result, the larger the effect. So when you get a big patch, there is obviously a large boundary, but by the relationship between the size of that patch and the perimeter is smaller. So normally, unfortunately, when you start reducing the sizes of these patches, these effects become more severe. The other one, as I pointed out earlier, again, is the size of the patch. And here is another example, because, another consequence of the size of the patch is that when you have patches that are big, you get higher chances of individuals that migrate to find those patches. An example that I used to give is many years ago, many years ago, when I was an undergrad, I came here to Hawaii to give a presentation. And in my way back to the United States, we were halfway through the Pacific, 2 hours into this flight, and the captain said, hey, we had a problem with our navigation system. We gotta come back to Hawaii. As soon as I hear that, I grabbed myself to that chair, and I was hoping for people to start screaming, for me to start screaming with them. And everybody was super cool, super relaxed, but I was terrified, mostly because I knew that size of the patch has a significant effect on the capacity to find that patch. And again, this is a good example because what I'm saying, if you had a problem with a navigation system, I would rather just keep going because I know that in front of me, you had the entire continent of America. You are very likely going to find it even if you deviate from the path. But if you turn around and you are going to be looking for this tiny patchy island in the middle of the Pacific, you had a higher time to find it. So I'm telling you that those 2 hours before until we go back to Hawaii for me were one of the most terrifying moments of my life because I was always concerned that the fact that the plane they had a problem with the navigation system could potentially prevent us of finding this island. I would have suggested, right, just keep going because with a big island in front of us, the continent of America, we will have a better chance to find the continent. So the same thing happens here with species. So you get patches of habitat that are bigger. When individuals dare to escape their populations, there is a higher chance that those individuals will survive somewhere else if the patches that are somewhere else are also big. If they are small, chances are that the individuals that migrate might not find those patches. And here you can see an example of that. Here you can get the size of the patches in hectares, and this is the rate of immigration. So you can see that how patches that are big normally had higher rates of immigration, again, just because of the fact that they become a bigger target that a species can get to. The other consequence of habitat loss that is related to metapopulations is the issue of past isolation. So what happens is this. So when you look at the individuals that are produced by a given tree, let's just use a tree as an example, it produces a lot of seeds, you are going to find that the high density of seeds is closer to the tree and very few individuals move farther from the tree. This creates what is called an unimodal frequency distribution of offsprings, and that happens almost everywhere. The offsprings of the adults are always closer to the parents itself. And here again, I think that this is plants, yeah, this is trees, but this distribution is found pretty much on anything in life, from animals to bacteria to trees, you name it. Now, the consequence of this attribute then is that when you start destroying the habitats, let's say that you had 2 habitats here, and you start destroying them, they start becoming smaller and smaller and smaller. What happens is that the distance between those patches increases. So when you increase the distance between patches, what it suggests is that a fewer number of individuals are capable to get there. Right? So only when you have patches that are closer to each other, you ensure that the higher density of individuals that are produced close to the parents can get there. So the consequence, again, of us destroying habitats is that we increase the isolation, and with that, we reduce exponentially the capacity of offsprings that are produced in one place to get to another place. And again, the rule of thumb is that the larger the connectivity, the larger the input of individuals. And that's the opposite with habitat loss. When we destroy the habitats, basically we make the places more separated. The other attribute of the habitat that is important to a species, to the maintenance of a species, is the quality of those patches. Here is an example, for instance. In this case, they had simulated populations of rotifers, and they simulated the quality of the patch by basically adding more or less food. And what they found clearly was that when you add more food to the habitats that are in good quality to produce a lot of food, these same habitats can produce a lot more individuals. Right? So whenever we go and do pollution or destroy the capacity, the habitats, what we also do is to reduce the quality of those habitats such that now they can sustain less and less individuals. So there are several rules of thumb when it comes down to the habitats in metapopulations. Let's just review them all. Basically, when you get larger patches, the populations become larger. The other rule of thumb is that when the patch is big, the HFED becomes small. When the patch is larger, so is the rate of immigration. When there is larger connectivity, right, that they are close, the number of individuals that can get to those places is larger as well. And when the habitat is good, you can sustain larger populations. And basically, we have tons of evidence to suggest these different rules of thumb. Here is an example, for instance, that shows that when you increase the carrying capacity, again, the habitat, the amount of habitat, the quality of the habitat, what you do is you allow to have more individuals. The carrying capacity goes higher as you affect these attributes, and basically what happens is that the species take longer to go extinct. This is an example here. So when you increase the carrying capacity, you can see how the species take a long time to go extinct. While the carrying capacity is small, the species go extinct faster. It's shorter, sorry. And again, that is an example here in which the carrying capacity is modified via these different disturbances that we do to the habitat. Here is another example looking at the extent of quality of the habitat, and here is another example looking at the effect of fragmentation in the probabilities of extinction. Basically, again, what I'm trying to point out here is that when we destroy habitats, which happens on land and in the ocean, and not only directly by us cutting the trees and putting bulldozers to make our houses, but also because we change the climatic conditions of those places. What we are doing is reducing the size of those patches, making patches that are suitable more separated, and the patches that are separated less capable of sustaining higher populations. And the consequence of that, of course, is that it makes populations prone to go extinct. Now, just like in the last lecture, when we were looking at overexploitation, habitat loss also has unintended consequences on a species. This one here is what is called the extinction debt. It's a concept introduced by Professor Tillman. And the idea of this extinction debt is this. Let's imagine that this is a patch that is occupied by a species, right? Now, and basically that's what I call population A here, and this is the number of individuals of that population. Let's imagine that you come along and you destroy this habitat and you cut it in half by maybe putting a road through it, such that now individuals from one population cannot go to the other one. Basically what you have done physically is to break that population A into two populations. So you can see now this population is one and this population becomes another one. In the last class, we saw how when the populations become small, sometimes they try to adapt, but most of the times they also face these extinction vortexes. So what happens is that when you destroy the habitat, you see the individuals there, but you have impaired those populations to the point that possibly they could get down to extinction, right? Again, all of these extinction vortexes that we reviewed before happening now as a consequence of us truncating the habitats where species can survive, because again, maybe we truncate dispersal, we might induce reproduction among close relatives when those patches become smaller and the only ones that are left there are parents with sisters and things like that. So you create this problem of inbreeding depression that we talked about last class. So the consequence of us destroying habitats, again, is making the populations smaller. As we point out here, the populations become smaller, but there is also a chance that the populations can go extinct as a result of these things that I just described there. Now, the problem of this, as you can see here, is that here at this given time is when we created the habitat loss. This is where you create the direct impact of habitat loss. This is when we cut the population in half. But the consequence of this habitat loss is actually seen when the species goes extinct. So as you can see, there is a time gap between the time that we created the impact and the time that the species went extinct, and that is what is called an extinction death. And that is one of the most worrisome consequences of habitat loss today, is the fact that we have destroyed so much habitat, not only on land but in the oceans, that it's possible that many of these species we see there, but they are already committed to extinction because simply we truncated the capacity for them to sustain themselves. So basically what you are seeing is just the remaining adults that will survive for a while, but once those adults go extinct, the entire population goes extinct because basically there are no young coming in to replenish those adults. And again, this time gap between the time that we destroy the habitat and the time that the species go extinct is what is called an extinction death. And there is a concern that many species that we see today are just, again, already committed to extinction despite the fact that they are still alive. So again, the impact of habitat loss is that it makes the habitats isolated, makes the habitats obviously smaller, they become smaller, and it also reduces the quality of the habitats. And we already saw that these changes on the attributes of habitat lead to impacts on the populations that then makes the species prone to higher extinction. That right there summarizes the class for today.